So originally we have a driving force of 200 newtons and the car is traveling at a constant speed of 20 meters per second. So we know that power is F times V. So the original power output from the car engine or whatever is equals to 200 times the velocity 20, which turns out to be 4 kilowatt. Alright, so now the car is instead of a level road, is going uphill against a gradient here. So if it's going uphill, then we'll need additional power in order to gain the GPE. Alright, so GPE is given by the formula mgh. If you want the additional power, you should think in terms of mg times delta t h delta t. Basically the rate at which you are gaining the height. Alright, and or you can think of this as the vertical velocity. So you can put in the numbers now. So the weight of the mass of the car is 800. So 800 times 9.81 times the vertical velocity. So what we have here, 20 meters per second, is the velocity, the speed along the slope. So if you want the vertical velocity, you need to do a 20 sine theta, where theta is the angle of inclination here. And do we know this angle? Yes, the question told us that the car rises 1 meter for every 8 meters it travels along the slope. So sine theta would simply be opposite divided by hypotenuse. So it's going to be 1/8. So you put in all these numbers, you will calculate the additional power required to gain the GPE to be 19.6 kilowatt. So of course the total power will be the original 4 kilowatt just to keep the car going at constant speed, plus the additional 19.6 kilowatt to allow it to gain the GPE at this rate. So the answer turns out to be 23.6 kilowatt. Okay, so this is one way of solving this question. Let me show you another way, maybe more complicated, but I think it's worthwhile to go over it. Let's go back to the original situation here. The car is going at a constant speed. There's a forward driving force of 200 newtons. So why is the speed constant? If the speed is constant, it means net force must be 0. So the net force is 0 is because this driving force is just enough to overcome the air resistance, which we now know is 200 newtons. Okay, so if we are now going up the slope but still at the same speed, then you'll still be experiencing the same amount of air resistance, 200 newtons. The difference between this situation and this situation is the gravitational pull on the car now has a component in the direction you are moving. Last time the gravitational force was downward, which has no horizontal component. Alright? Now because you are going at an angle up the slope, the vertical downward force of gravity actually has a component in the direction you are traveling. So what is this amount of, what is this component here? It's actually mg sine theta. Alright? So to maintain the car at a constant speed, you need the driving force to be more than 200 newtons, because in addition you must also overcome the component of weight in the direction along the slope here. So now we know this force here will not just be 200, it will be 200 plus mg sine theta. So the power that's required is of course still calculated by F times V, but the F now will be 200 plus mg sine theta. So m is 800, g is 9.81, and of course there's a sine theta, which is 1 over 8, right? So mg sine theta. So there's a 1 over 8 here. So that's the driving force multiplied by the speed 20. You will get the required power, and it's the same answer. Alright, so either way, it's up to you. You will get the same answer. Okay, ta-ta!